Just so that give you a little bit more entire overview, what we're gonna work today is to present another form of what we've been called a procedural content generation, which is a built-in framework since 5.2 and version 5.2. And what does actually do is PCG framework was designed specifically for a variety of design for variety of people, developers, artists, as well as for designers who has to create procedurally generated landscapes. In this case, we talk about spawning meshes as well as creating a very cool environment within just a simple form of using nodes. In this situation, where you can just basically have its own framework editor, where you can pick up a few nodes that does help you to create like a very simple algorithm in order for you to generate the results, which is the procedure generation here. So for this reason, that's why it's so significant that Epic Games has released this tool for the reasons to make sure that it doesn't complicate the other workflow of entire pipeline for generating words as a word building process. Where you can basically do is to use its own separate framework. For this reason, like we have it for materials, editor of blueprints as well, where PCG comes in as a separate tool set. In this case, to help you to create complex words, in this case, environments, within just a few bars, click of a button. All right, and for this reason, what we're gonna do for this session, we're gonna present, of course, and I'm gonna basically present for you guys how to do this with this variety of different PCG tool sets, which are available within the framework. But before we begin our journey with PCG, what I'd like you to explain is that how does it really work? Well, technically, procedural content generation is like a sort of a way to algorithmically create spawn the assets within the environment using the rule-based systems. So in this case, we have is the node-based framework, where basically it does it pick up the point data within space, and based on this point per and so-called data which are being sort of spawned within a vector space, it spawns the objects, which in this case are static meshes. But it does this in such a way that it's non-destructive. In other words, what it does, it updates through the graph. So every time you do something in the graph, it already updates inside the editor without you waiting until it compiles through it, which was pretty much done traditionally using blueprint classes. But because blueprint classes has been pretty much overcomplicating the process, handling the process of your CPU as well as memory, what in this case PCG does, it's kind of utilizes for using different sort of like approaches to this, which I will explain in a second more. But for this reason, why PCG is super comfortable, because it also works for scalable word building. I would say processes. So in this case, you can populate vast areas very efficiently using instancing. And that's so cool because you can actually do is just by creating few nodes algorithmically, in other words, create like a very simple structure of nodes. You can basically populate using instancing. And that's also very well opportunity for like a data-driven placement. So let's say you have some data assets that you can also enable to work within the PCG framework. So instead of you doing all the operations uh, literally within the, like we did the blueprints, you can actually your own data assets and then basically use this as a connect them inside a PCG where it utilizes all the information and it knows what exactly the rules it has to set for this data specifically, depending how you're working and organizing your PCG structure. So for this, there are instancing methodologies, I call it, in PCG. One of them definitely is like a common thing, instance static meshes, where what it does, it basically instances few instances within few draw calls. As you can see here, it has a little bit more CPU overthread, so everything does it's within the CPU processes, and also it is another form of optimization. But of course, this also it's a good way of representing how many by multiplying amounts of like I would say meshes that are being spawned within this and rendered within this space. It can also be able to generate a lot of meshes at few instances. But also there are other much better methods which also utilize this, which kind of called advanced static meshes, instancing mesh methodology, which is the hierarchical instant static meshes instances. So In this situation, hierarchical is a little bit more, I suppose we call it more organized because what it does is all does in one draw call, the static meshes, but at the same time, it uses LOD systems. So depending how far you are, the cooling process also takes place. So for example, closer you get, you see bare clear object. The further away you are from the object, the objects are still keeps good quality, but at the same time, it turns into low polygon models, making sure that there's enough power for this to utilize through CPU and also in GPU at the same time. So, um, well, you might ask yourself, why PCG? Well, there are certain reasons for that. And of course, traditionally, it's always been sort of like a way of generating as a spawning meshes within the environment, which was mainly for the reasons to, I mean, mainly uses the standard way using foliage tool, where you can basically draw as it paint over meshes, as it landscape with meshes, let's say foliages, as well as other assets that comes as starting meshes. But because PCG came like a better sort of case scenario to generate faster, but at the same time much more optimized way. So that's why PCG became more of a handy tool for creating game worlds as well as open environments. Uh, from my experience, I came across this a lot of times these days, where you have some adverts or like anything that relates to bigger environmental distribution, and that's why it was so handy to do this in within the virtual production space. So that's why that is very handy a tool where you have to have a quick overview of some elements that are being spawned within the space bar. What if there's something that needs requires few changes and that doesn't let you developer to overcomplicate things? Because there will be times where a director or anyone, a lead designer who steps in, wants to discuss what is it that needs to be changed because we need to do it very quickly. PCG comes very handy for this because you can do is basically pick up element you want and very quickly change the mesh you don't want to work with for the final output of the production. So that's why these PCG tools are very handy for this reason, so that you have a much more flexible, versatile pipeline for this reason, so that doesn't complicate things with just using blueprints, because you can then use PCG to do quick solutions, provide quick solutions for something that is very complicated, but you can then turn into like something very simple. That's why having things like architecture as well as simulation scenes, even interactive experiences can be very handy for this reason. So I think it's good to know that PCG, it's a kind of a good thing because nowadays PCG became like less experimental. It came out of actually phase of being experimental, so it's no longer experimental. So in 5.7. And for this reason, we can actually do is work on 5.7 version of Unreal. So for whoever are participating in this class, they have to also remember that it is 5.7. So and sorry, and so this also, before we jump into practical session, for those who are not familiar, that I'm also an author of the book Procedural Content Generation Unreal 5. So for those who have not been yet also notify about this. This is the links for you guys to look, check it out. I wrote this specifically 5.4 when it came out. Of course, there are a few changes being done, but this is mainly for those who happens to be at the beginner level. And it's a very good book to for people, folks who happens to step into PCG and they like to know anything theoretically and also practical way at the same time, and they're very novice level. So that's why this book is ideal for those individuals. So feel free to look into this when you have a time. And let's get step into the practical work. So let me just quit this one. So yeah, before we start in, what's so important is every time you work with things, it's always make sure you launch your Unreal. And you, of course, because the project is already ready, I just want to show you quickly what you need to do to make sure you proceed with this. Um, um, so let me just have a look. Yeah, there you go. So when you're gonna create a new project, we can go start with blank. It doesn't matter. As long as you are working blueprints, that should be enough. And this is pretty much it. And then go click recreate to go to proceed next. So, but because I already have a project, once you get into a project, the first thing you should always remember PCG is not gonna just work instantly because it's a plugin. So you need to make sure you enable the plugin. The first thing you need to do is to go to Edit, go to Plugins tab, write a PCG, and also remember, because that PCG inside 5.7 got more, I suppose, expanded in a sense that it can have more extensive plugin setup. So, but because for this particular reason, you don't have to click all of this. The only thing we really care the most is that the first one, Procedural Content Generation Framework, and also Procedural Content Generation Framework of External Data Interop. And for the reason, because some few nodes that are only activated within this plugin, so that's why I keep that. Of course, you can enable all of them, but for this particular exercise, it's not necessary to do this. So we only stick with those two at the beginning. So next thing is we're gonna do some very simple examples. So let me explain this. So there are a few methodologies of how we can step into this. So because I already have a landscape here, and also I want to show you there are different types of, we call this samplers. So PCG has its own formula to how you can procedurally generate your outside environment. Let's say you have a landscape. Well, there are a few ways to do this. So for the first one, what I'm going to show you is the surface sampler, because there's also spline sampler, there's texture sampler, and also mesh sampler. But this is what I'm gonna do. We're gonna have 4 different examples, which I try to see if we can fit it within the 45 minutes time. But for now, let me try to crack on with this so I can show you what is it that the most ideal and the most standard way of creating PCG, very simple PCG. So in this case, I'll just create a folder. Let me go click, and I'm gonna go and look for PCG, and I'm gonna just click on PCG graph. I'm gonna create a new one. So you don't have to even click this. We can just dismiss that. We can just go and create empty graph. In this case, I'm gonna call PCG surface sampler, just like that. I'll double click, open this up. And let me just very quickly set things up so at least I know what I'm dealing with. So, so what we're gonna do now, a very simple example. So for this reason, we have this is pretty much a framework, a meat of entire structure, a skeleton of this whole PCG editor here. So at the moment, you don't have to worry too much about any other details than what you have here, because what we're going to do, we can actually introduce some of the nodes we're going to work with. But because at the moment, we only have like something like a volume, and volume is, if you drag and drop into this, it doesn't do much because at the moment we haven't given any much of instructions. But because this is a very simple thing, because it's just empty, so what we're gonna do is to start adding things that we need for this particular example. So first things first, we're gonna do is introduce get landscape data, which is the information that you are going to feed in as an input into this structure that we're just gonna create. And what's gonna do is this data, whatever data we have here as a volume, feeds into this specifically through this landscape data. And because this data landscape data, this is our actor that we're dealing with for this environment, we're gonna then use this as an input and then feed this into surface sampler. So let me just go and then right click and let me search for surface sampler. Now, as you can see, this is the main thing that only making sure it works, because this is the only thing that it makes gonna generate your PCG overall within the environment. So it's very simple, just plug this in. Another thing I want you to do is also test it to see if this works, because at the moment there's nothing going on. And obviously, if you want to go check it out, see what's going to happen if you have this set up, you can just go add debug and then click on this and see what's going to happen here. Now we see all this different between white to black coloration, like all the shades of gray. And this is because each point has its own unique information. So, because what happens, I use the debug, which means it's gonna only use the cube, we call it PCG cube here as the debug to debug the information of the position of each point in space. But because, as you can see, I've seen it on the slide of the presentation, there's some points in space, which is kind of generates the points within this landscape. So also what we can do is to inspect what happens and how many number of points we have within this given volume. And to do this, we can also inspect it by pressing A. So you see there's this like a kind of orangey yellowish tint of like little cuboid there that shows you the information here on the attributes. So gives you all the information at the bottom where the attributes are set up of like what is the position at X, Y, Z formation. And also gives you information what is happening to its position and scaling. And as you can see, scale at set at 1. And obviously, it gives you all the information you need for this to understand what's happening to these points. At the moment, currently, from what I can see, there have been generated 229 points. Even though it's not really much visible, it's very hard to tell whether 229 points here. But because in this case, Surface Sampler is provides you this information because this is what it believes it generates within the space. So it gives you all the coordinates that you need to know within that given volume space. So now we can do is to disable by pressing A again. Now let's go and play around with few extra nodes that we are given on this one. So, but because for this given example, we're gonna create a very simple forest. So bear with me. I'm gonna continue with the example. So let me just remove the debug node and let's start adding some four more nodes. So in this case, I'm gonna add transform node. So and also I'm gonna add static mesh spawner. So what you see here is a transform point. So because we have surface sampler, also we try to connect with transfer points. So that transfer points will basically provide enough information for each point to see how it behaves with the transfer point. Basically, what it means is that this transfer points allows points to either rotate, offset, or even scale at the random with the random numbers. So, for example, I'm gonna plug this in. And also I'm gonna plug static mesh, which static mesh spawner is the main meat of what's gonna spawn, which is the static meshes. So for this particular example, I'm gonna do add mesh entry here. And I'm gonna do is basically add as not this one, sorry. I'm just gonna add static mesh here. So for this, I have some examples of trees. And of course, this is the trees here. And as you can see, it generated all my static meshes here. Also, it spawned on that given space. So make it more interesting. Let me just try and see if I can try expand it, just scale it just like that. And as you can see, all uniformly being instanced all along this area here. Obviously, it does kind of look weird because it looks very even, so it doesn't look natural. What about if we can randomize a little bit? So that's why transfer points comes very handy. So we can chain offset. So let's say I go minimum 0, let's say to maximum 100. This is for the, as you can expand this is the XYZ coordinates, just like we already inspected in our attributes nodes here, attributes tab, sorry. And I'm gonna do the same thing for Y. And what I also want to do, I want to make sure the scaling is kind of different. So let's say set current to 1. So let me try and see you can set to 0.5. So automatically X, Y, and Z are being applied. So now I can see there's a bit of difference, right? Okay, there's something going on, which is good. We can even go smaller if we wanted to. So let me just go back again, 0.25. Now you see there's a bit of deformation that has different scaling and so on. And we can do the same thing for rotation. So let's say I'm going minus 90 to the 90. And now you see that all the formation differs from each tree, right? Cool. How about we can do an extra bit more work around it? So how about we can add other elements to this entire spawning spree here? So to do this, you can do two ways. And what you can do is use your static mesh spawner. You can add more extra elements. And add, let's say, let's see, I go a bit more here variety. So I go seedlings, which are boulder, as these little stones. And you can see they are here. They are being overpopulating just like that. But maybe there are some cases where it sort of overlaps. This is a good way to also add more meshes on top of existing study mesh spawner. But what if you can actually do is slightly, maybe change a bit of variety. So for example, you wanted to make sure that some of these stones don't overlap. As you can see, they're kind of overlap, trying to hit some of these tree barks here too. So there are some ways to avoid this. And I'm actually going to show you how I actually do this. So for this, what we need to do is to make sure we already have these what's so-called trees. So let me just go and comment this. I call these trees. Let me copy this. I can just do copy and duplicate it. And what we're gonna do, because we're gonna make sure there's like different things, which is gonna be these kind of boulders, which is this little rocks there. I'm gonna comment this. I kind of go rocks. And because I can just then go back to my mesh entry, I can remove it. And I can add it here. I can remove this tree and then keep it as a boulder. So now you can just plug this, make it work this way. But as you can see, obviously something is wrong because this is already overlapping with the trees because it copies the same position of the previous graph here. So that's wrong. And to fix this, there's another way to do it. And I'll show you how to do it. So there's something called difference node. What does it allows you to differentiate, as not differentiate, more like a makes the difference between what is already spawned and subtract some of these information points from this given node structure into and then apply these missing points and replace with something new. So that's why what does it do is like a subtraction. So remove some of the points from the source and add some points from the difference input node, which I'm going to show you how this really works. So I'm going to do is go to difference. And as you can see, my source here is going to be obviously the trees. So I'm going to disconnect this one. I'm going to plug this to this. And what I'm going to do is then add also another two nodes because I also want to make sure that difference nodes only doesn't rely on difference node because you also have to add some bounce modifier and also there's a called node self-pruning which helps you to remove some overlapping points in space. So I'm going to right click and I'm going to add bounce modifier and let me just go and also look for self-pruning and let me plug those two in. And I'm gonna plug between surface as well transform points because this is something crucial for the information to be first fed through surface sampler into transform points. But because we also have to add it connected to difference here, no, and from self-printing I can add it to as it connect to difference point. So now as you can see, obviously something happening, but my trees are gone. Okay, that's fine because they've been sort of like over dominated by rocks, and then it just removed the trees, which is fine because this is something we all gonna fix together here. So, but for this, I need to set up my first mode, sorry, not mode, but density function to binary. And at the same time, what I'm gonna do, I'm gonna play around here with my bounce modifier as well, self-pruning. So first things first, what I'm gonna do is that changes from small to large, so I have a bit more fun with this. And I'm also gonna slightly play around with these numbers here. Okay, let me check. And also I'm gonna check if I can translate a little bit so I can then play with these numbers. Let me check. Let me check this here. Okay, so now you start seeing trees start to appear because now what we've done, we have been applying some more formulas within this whole PCG structure. So what it does, you can actually do is then use this to manipulate how your points are being distributed in space. So we can actually set up the numbers here. Now you see some of these rocks stays in, some of them be removed because the trees start to appear on top of these existing rocks, and then rocks are being removed at the same time. So that's you see, this is a bit of your fun way to experiment on this with just very simple structure algorithm that is being shown on this given example, which is very cool, right? So this is the thing about this one. So let me just check something here. Okay, save it. Cool. So this is the one way of creating using surface sampler. All right. All right, so that's cool. All right, cool. So this is like another way to do it. And of course, you can make this bigger if you wanted to. There's also a thing called unbounded. What it does do, if you click on unbounded, but always be careful because if you click on unbounded, what's going to happen? It will start generating all the mesh, spawning all the meshes outside the volume. So if I click on this, as you can see now, you have this little very cool thing that everything that within the volume space are being generated using this so-called structure that we've created. But as you said to Unbound, everything is being basically spawned outside that volume as well. So you can move around. Obviously, it's heavy, so be very mindful about using this. That's why I don't want to carry on with this one. And I'm just going to turn this unbounded right now. And I'm going to do is to save this one because this is something we already created. And we're going to jump into another example. All right, so that's a surface sampler. So this is what you just see. It's a surface sample example. Now, let's go and do something different. We can also introduce another way of generating PCG using splines. Splines are also very cool because you can do is create roads or you can create fences or you can create even like a little like we have here with volume, but within the interior space of the closed loop, we can also generate trees as well as forests as well. But there's a caveat to it because that also goes down to some performance, but there's also pros and cons of using splines for certain different use cases as well. So, but because I want to present you some other ways of giving you some options here, what you can do with this. So for this particular reason, I'm just going to show you how PCG Spline works. So I'm going to create an empty graph. I'm going to go PCG Spline Sampler, and I'm going to just double click on this one. And like what we've done, in this case, we're going to do, but this time with Spline. Um, okay, so let me just go and look for scan spline data. Because we had before landscape data, now we are reaching as it using input as the spline data, because for the reason because you're going to use spline for this. So I'm going to look for a spline sampler, which is this one here. And I'm just gonna easily plug this in. Of course, it doesn't do much because we're gonna use Spline for this. But because you can't just use Spline into this with the volume because it's not gonna work because you need to have a Spline property for that. So I'm gonna also make sure that also what it does, it projects into my landscape because what does usually happen is that Spline has its problem because Spline sometimes doesn't project properly into landscape. So you need to make sure you also give information, in other words, instruction for objects to spawn on the landscape. But I'll show you that in a minute what I mean. So for now, let's leave it as it is. I'm gonna also add, let me just add transfer points. So at least we have this working as well as static mesh, which I can then, maybe for now, let me add some mesh entry. So let's see, look for a tree. All right, I'm gonna just add this here. I'm gonna add that too here. And also one thing for certain, okay, let's leave it for now. I'm gonna do something very quick. Because with spline samplers, you need to create blueprint, okay? So for this reason, I'm gonna go blueprint, click active. I call it BP spline tool. I got a cool tool. I don't know why. It's just like, it's a kind of a thing to say because what if you're an environment artist or someone from tech art or dev or even a designer who happens to create tools. So in this case, you can say that you can also create a tool because this is a kind of a tool. I have to say like a blueprint, which basically helps you to generate word. It's like a word building tool that helps you generate environments, right? So that's the reason I call it Spline tool. So now what I can do is then go into my Spline tool, and first thing you need to do is to add PCG, integrate PCG component here because this is not gonna work. So for this reason, because I have already PCG spline sampler, so I'm gonna just to drag and drop into this graph space here. I'm gonna compile this, and also because at the moment it's not gonna work, because if I just do that, it's not gonna do much. Because what we need is also add the spline component. So I'm gonna go and look for a spline. That's right, compile this, and now you see something's happening. Oh wow, cool. I can just drag, add more points. As you can see, it generates more trees around it. And also you can increase the number of trees along this spline. But obviously this can also be a little bit expensive. But for this case, it gives you a little bit of variety what you can do with this. So let me do to make it more fun as well as more usable for this specific reason. And what I'm gonna do is to add some graphics, parameters in the graphics graph settings. So I'm gonna do is that graph parameters. Yeah. So let me add some. I'm gonna click on add parameter F2 to rename it, and I'm gonna call it spawning distance. Distance. And I'm gonna call on spline because it's gonna happen on spline. I'll show you the differences. Always make sure you don't let it set at zero because if you set at zero, that means if you start making work for your spline to generate, sorry, if you leave it at zero, if you're gonna generate all the meshes along the spline, what's gonna happen? It will crash your compare because what it's going to do is to infinitely looping your meshes along this spline, which that's just something you want to avoid at all costs. So what I will do here is set to minimize 100. All right. So what's going to happen? It will spawn mesh every 100 units. We call it every 100 units within space of the spline itself, right? Along the spline. So, but because I already have that, I'm gonna look for get spawning distance on spline parameter that I just created, and I'm gonna do because this is your so-called subdivision per segment. I'm also gonna set to distance here. So I'm gonna literally do is to set to add it to distance increment because this is what literally does. And I'm going to see what's gonna happen here now. As you can see, it started to generate some results. So what I can do is increase it here, decrease it, and just make it look cool. Because 100 units, just to give you like a quick overview, 100 units like 100 centimeters, right, inside Unreal. So, and to recognize this is when you look at this little grid here, that gives like 100 units in between, right? So this is like your 1 meter length of your space there. So that's cool. I am also going to add this into this space there, which is that inside the so-called blueprint. But because at the moment it only refers to information that comes from that PCG graph, but I also want to make sure this parameter is also exposed to the blueprint. And to do this, what you need to do is to go to construction script, and we already have, because this is the parameter that has already been exposed for this. So I'm gonna do is then look for the graph instance, which actually does it accesses this PCG structure of this graph. And I'm gonna do is to set my float, which is the parameter that comes from the graph itself. And also because now you can see it has name and value. Well, the name of this specific node that we already created, which is this graph set spawning distance on spline, I can just copy this and make sure it's exactly matching the same name, otherwise it's not going to work, and copy and paste it right here. And what I'm going to do is to extract this, and what I'm going to do is to promote a variable. I'm going to call it the same thing. So for the naming convention, it makes it a lot easier. Make sure it's set to public, which is visible. And also I'm going to connect this with this one. I can then compile this. But one thing for certain, I need to make sure my numbers are not too low and not too high. So I'm going to set my, yep, that's right. I made a mistake. As you can see, like you guys remember I told you that I need to always make sure my spawning distance is more than 100. And now what's going to happen? It's running out of my memory. So as you can see, it's just crushes my memory. All right, so let me go and kill it. Unfortunately, this is the mistake you always have to watch out for. Don't make the same mistake I just did. All right, so I'm just gonna have to kill this and go back again. It is what it is, but you always have to keep in mind those other things do happen. All right, let's see if this works. Restore it. Should be all right. Okay, let's have a look. It looks like it's there, which is great news because we don't want to go to it again one more time. So let me go and check the numbers here just to make sure it looks clear to me. Okay, so it looks like it's gone, which is fine. All right, so now we have this. So we're going to do it very quickly. Let me just do this. Bony. I gotta set to 100 minimum. Get on supply. And I'm going to make sure it's subdivision distance. Okay. All right. All right, cool. And now I can just come. Okay, let's go to our spline here. All right, we need to create it again and again. That's no problem. It's something we already have it, so we can just do it very quickly without taking too much of our time. And I'm gonna also add spline. Okay, compile this, should be fine. Cool, we got trees there. Let me just expand a little bit more. Okay, cool. So now let's not make this mistake. So I'm gonna create the variable right here, call it spline, set it to float, compile this. I'm gonna make sure it's set to 100 there. Let's do, let's say 1000 range. And we're gonna start as 100 as the minimum. And I'm gonna bring this like we've done it, the graph instance, graph instance, set float parameter. And also let's just use the same naming. And I go and just use this as our parameter and make sure we do expose this so it works. Let's compile this guy. And now we got something work. which is amazing because this is what we're looking for. And okay, let's see. So now I can go do this. As you can see, I got the range there and it works. And also, I'm not sure if you guys noticed that, but every time I move upwards like this, it's just literally floating on there. But there's a little fix for that, and I'll show you how to do it very quickly. So just bear with me. As you can see, that's why I'm not, if you might notice, I've introduced this projection node. So what it does, it's basically it projects this graph that your sampler that you've spawning your points in space, and then sticks them into this surface of the landscape here of the actor. So what you want to do is to make sure that really all these trees are being generated along the spine, also the floor of this landscape. So to do this, what you need to do is to make sure you connect your spline sampler here, disconnect it, and also because we need also a landscape information, which is this one here, get landscape data, and connect this directly to projection target. So now as you can see, now these are being sort of sticking into the floor. So now every time I move, always gonna stick to the floor using this projection node right here. All right, so this is something very handy for you to remember this. So that's cool. And also I want to show you very quickly is that you can also do very interesting stuff is that you can close these so-called loop here and also make it work inside the interior of the specific spline tool. And to do this, you can actually do is to make sure maybe as an experiment, I'll show you what you can do is to use this spline that I already have and set it to on spline and set it to interior. But because it doesn't give you error, the reason why it gives you error, because the blueprint that you're currently working with, it doesn't have a loop closed, so you need to make sure that loop is closed in order for this methodology of mode to spawn these meshes inside the interior. And to do this, we can do is to go back to spline, right click on the spline point, and what you're gonna have to do is make sure you're kind of aiming that spline, let me just right click there, and also click on spline generation panel. So then you have the setup to change these different types of shape. But because for this particular reason, I like to do work with circles, I'm gonna set my radius to 1000. So then it works within the 1000 unit space. But because we also need to make sure we can close this loop, so what we cannot do is to then close the loop here on the details panel. And now, because the problem there, there's too many points being generated. So as you can see, my points are being generated overlapping. So I'm going to remove some of the points there because I don't need them. I only need these 3 point spaces, right? So, and I'm because it's also, as you notice, my actor center pivot, it's a bit far off from the position. So what I'm going to do is also make sure I am going to reset this. So I'm gonna make sure my position of the spline is set to somewhere right in the middle, just like that. I'm gonna literally do is compile that position. So now I'm going back to this. Let me just remove this guy and we bring this one more time, a new one. So now we see nothing's happening because we need to also add some information to our PCG graphs to make sure it works. So now I can do, because at the moment it's only working within distance increment. So what I need to do is to create a new, oh, let me just leave it there, it's fine. Let's create a new parameter float. I call it spawning distance on interior. And also let's not make the same mistake anymore. So I set to 100. And now I can do is to bring this guy here. So we call it spawning distance on interior. And for this reason, I'm gonna use the one that's interior sample spacing. Okay, that's cool. Let me just organize a little bit clear. Okay, we got working. I've saved this. So now I'm going back to this spline tool right here. And I'm going to go construction script. And I'm also going to introduce a new set float parameter, which is this one. Okay. And let me just disconnect just in case we don't want to crush this anymore again. I'm going to call this on interior. Also make sure that's the same naming as the one we have already on PCG graph there. And I'm going to just compile this. It's set to 100. Compile this. And now we need to do is to make sure it works. So I'm gonna check something on my graph. I want to check if also, because maybe Because we need to make sure it's set to unbounded because we are on sanitary, so all this stuff gonna be generated inside the closed loop space. Yeah, there you go. So now you see it's all started to generate like this. It's so super cool, right? But there's a problem because what happens, there's a little issue. As you go further, you start moving these points and generate more points. The performance might drop a bit, all right? And of course, it doesn't look even, but it's okay. For the time being, it's good for you for to exercise with. So I'm gonna is also increase a bit spacing. So let me just check which one is which. This is the one. Okay, cool. Um, Let me go do a bit more work around this. Because there's also something called work with GPU execute. So what does it mean? That currently that you're dealing with, the static mesh spawner heavily is based on CPU and memory, right? Which is fine because this is like how you procedure generate objects using draw calls based on CPU power as well as memory. But we can also do is to use this to substitute this with GPU, which means Unreal has introduced this idea of another form of executing your PCG using GPU, which is definitely a faster workflow. So for this, what I can do is then also utilize using GPU. Now you see that GPU is on. So every time I move this around, it's a lot faster, and I can even duplicate it. Very simple. But what comes down to is that obviously I want to have a bit of switch in between these two. So I want to work with CPU and GPU. And there's a little trick I can show you how to do this as well, like I just showed you the blueprints. What we can do is then go and look for a branch. And this is like a branch where you can create like a Boolean. So let's say you can enable to work with GPU or make it work just traditional how it works with static mesh spawner on the CPU level, right? So for this one, I'm gonna just connect to this. I'm gonna disconnect this. And I'm gonna click on this as it add to that, and I'm gonna literally duplicate him. And I'm gonna literally do is to turn the GPU here, and I'm gonna activate GPU on this one, which is already activated. And I'm gonna create a new parameter. Let me just call this GPU on off. And this is gonna be our Boolean. Okay, so I'm gonna then get GPU on and off. I'm gonna just plug this in so then it will happens that you can have a choice and then we're gonna use expose this choice as an our active blueprint. So in this instance, what I'm gonna do is then set Boolean parameter and I'm gonna call as well GPU. Let me just say that I know I copied the same naming. So I'm gonna GPU on and off. Okay, so I gotta plug this in and I'm gonna create a new variable which is gonna be on and off. I gotta expose this, compile this, and also, so what's gonna happen now? Okay, cool. Now what we got? So let me just show you. So what's happening now? Currently, we are just working traditionally on this a setup of just instant static meshes. So let's say we duplicate this, let's make it a little bit bigger so then we can see the performance difference as we go along with this given example. And let's say I wanted to go drastically low as a distance wise. So now you can see this whole forest being packed into this one thing. You can see that start is gets a bit slower, right? And obviously you can go as high as you want it to. I mean, I don't know, go big, and you can see how slow it gets. Okay, how about I don't want to be too slow and I want to comfortably work with it? Well, you can actually do is to select the spline and turn this on GPU on thing. And now you see how fast you can work with this now flow, knowing that it's not gonna perform as poorly on your PC while working on this environment. All right, so it's cool. And you can actually do this experiment in so many ways you wanted to. So it's very cool that you have this flexibility to add this extra, functionality like you do in Bluebeats, but within the GPU framework, and then exposes inside the blueprint like we have it here, okay? But okay, let's just go back and just close this one or just remove these. All right, cool. And what happens if I wanted to maybe, okay, let me just go and see what happens if I just make this space there. Okay, so let me just go. And I wanted to show you something as well, very cool. So bear with me. So now what I can do is to create like a forest, let's say, and let's say I'm very happy with this. Let me just make it a little bit more prettier, okay? Even though it looks very even, this is down to using the transfer point. So if you wanted to change this, so it's your thing you can do on this end. So you can just go and change formation here. So it looks much prettier. I can set it to 0.25, change the rotation, minus 90, minus 90, and then 90 degrees. And then maybe change the offset to like 100 difference. I see there's a bit of the forest there. It doesn't, it looks different now, so it's cool. That's something that changes the variety of random placement of the static meshes in space. And what if I wanted to just keep it like it is, like this? I'm very happy with the results. Well, there's two ways to do it. You can actually do is to generate, clean it up. Not to clean up, sorry, my bad. You can clear the PCG link, which means it's gonna create the stumps. Okay, sorry, my bad. I think because I need to go back again. Because I'm on GPU, my bad. So I'm gonna turn this on back on. I'm gonna generate one more time, and I'm gonna clear PCG link. And what's gonna happen? It will create like a PCG stamp. So now you see it turned to this static mesh, right? It's very cool, right? So now you have this static mesh. But because you cannot modify anymore, so this is something you always have to keep in mind that when you create a stamp, it just creates just like plain stamp into the space. But this is very cool if you wanted to just keep the results as they are in this specific area, save it and carry with another generating environment here. So that's something to remember. And also if you want to bring it back, what you can do is to go to PCG, generate it, and just have it go like this. Yeah. Another way I was going to show you very quickly is to go and create these buttons on the side. Instead of you clicking on PCG here on the feature, you can actually create like a little button here. So what we can do is then go to our spline tool and go to the event graph. And let's create a custom node called stamp. And I'm gonna then drag my PCG node and I'm gonna clear PCG, making sure it's a clear one. Yes, that's right. And then I'm gonna also create another custom event. I'm gonna call generate. And making sure that these two are exposed on editor. I'm gonna do the same for this one. And I'm also gonna do is to generate this. I'm gonna force to generate this. Okay, cool. So I'm gonna compile this, and now you see there are two buttons there. So every time I move, I can stamp it, and I go to another one, and then let's say click on generate, and we'll generate another results, and so on. So this is like some little thing to keep in mind that you can do easier and much more efficient workflow for, let's say, this particular example. Okay, so I don't know how much time we got. I think we go past like Zubaida. What do you think? We have 20 minutes maybe?
You can, I think you can take even 30. That's okay.
30?
Yeah.
Okay.
Yeah.
All right, we got
No
30
problem.
minutes. All right, thank you. So
I'm
far, so good,
enjoying this.
right?
Yeah.
Thank you. Really appreciate it. I hope everyone else enjoyed this time. All right, and nothing overcomplicated. I mean, that's why the video is for this reason, for you guys to rewatch this once more. So for this reason, so let me continue. So don't want to take too much of a time talking. So let's go to another section of this exercise. So let me introduce you to another, maybe just remove this, it takes too much space there. And we're very happy with this one. All right, cool. Let's go and check something different. All right, let me just close this guy and let's create another example. Let me think. How about we can do is then create maybe texture sampler. All right. So what texture sampler is, it's like so you can actually generate, yeah, you can generate environments based on this texture information that you have from from the texture information. Yeah. So there's called sample texture in PCG, and that's what I'm gonna show you how you can activate this and make it work with the PCG framework. So to do this, I need to create a new PCG graph. I'm gonna basically create a new empty. I call PCG texture sampler. We may call it this way. So, all right. So, because I showed you already, there's a surface sampler, a spline sampler, and then with the texture sampler, the idea is very similar. But as I said, you basically do is then you use the texture information to generate the points in space, knowing how information is being distributed within the texture itself, right? So to get more clear picture of it, let me demonstrate how this really works. Okay, so first things, I have this sample texture. I also need to make sure I have get texture data because I need to do is to feed this information from texture and then, I mean, as an input, have this information, feed this into my base texture, which is the sample texture. But because currently I can just plug this in, nothing's gonna happen. But also we can use these nodes here, which I found it very surprising because at the moment, lots of these examples with the new PCG framework for 5.7 doesn't really utilize this information anymore from this. You can actually use the specific nodes for it, like I have it for this one. So in this case, I can plug this to get landscape data. You can also use this, but surprisingly, it's not as popular as much as I noticed that. So it seems like there's another provided solution for this. You can actually use get landscape data or get node data, I would call it, to feed more, yeah, to do specific certain operations within PCG. So, but because there's already feeds as the landscape data, I'm gonna just plug this into this and I'm going to make sure that it generates something, right? So let me go and first to debug this. I'm gonna use the debug for this. But because currently it doesn't do much, that's the thing, because there's nothing going on, right? And the reason why, because we didn't add any texture. But for this reason, I'm gonna use Unreal Engine texture, which is the Unreal logo. I'm going to use this for this, so I'm going to use the Unreal logo. And now, what happens if I plug this to debug and see what's gonna happen? What's gonna come out? Where is it gonna come out? So, uh, oops, so it got a little bit too big because I made a mistake here. Let me just go fix this. And I think the reason why, because I did silly mistake of knowing that this is mainly uses, yeah, I think the reason why, because I'm using get landscape data, which is the entirety of this. So I need to slow it down by basically, yeah, I think I need to make sure I use this one instead. So let me just turn this guy off. Yeah, it's gonna take it's exposure, so it's gonna take time to get back to normal, which I find it very strange. It's a bit buggy inside Unreal. Uh, yeah, it's I don't know what's going on. I lost my lighting. Okay, now it's working. Yeah. So because the debug node generates the cubes with the emissive lighting on it, that's why it's got really dark. So let me go and then add this. Let me just check. Yeah. And then let me go, and then I am going to change to my landscape data information, which is this one here. And I'm gonna plug this in. Now, okay, good, it's working. Something's happening. I'm going to make it a little bigger, possibly because it's a bit more. All right, maybe because it's also because there's also the texture data that's currently on is on alpha RGB color, where we need to change this channel to something like green. So now you start seeing that logo start to appear, right? Even though it's not clear, but at least something is coming up with that. And make it a little bit bigger so there's a bit more uh, sharper looking formation of this given example. As you can see now, the bigger it is, the clearer that image looks. And it can be slow, obviously, because the generates a lot of cubes in space. But for this, I'm gonna replace this and I'm gonna start a mass spawner for that reason. So I am gonna do is add something. Um, okay, cube up. Keep shapes. All right. Not maybe now that one. I'm gonna use something else. Um, hmm. Maybe I'm gonna use something else here. So let me. If I'm not sure if I have some examples of a given. Uh, I must. Oh yeah, there you go. This is my mesh. Yep. Oh, it's a bit slow. Okay, now it's something is picking up. Excuse me, it's big. It works. But yeah, as you can see, now you see all the cubes are being stuck up on each other. But let's change this density because it's too heavy. Um, Texture data. Check if this works with 100. Also, I'm gonna make sure the number of textures way too high. Okay, let me check. Maybe I can just then distribute a little bit further down the road. Uh, oh, maybe you know what? Let's see if I can just make it smaller. Basically, it's just gonna be easier this for this given example. So I'm gonna make it go 20. Yeah, that's fine. But anyway, this is something like very cool to remember. It's like a very cute looking Unreal logo. Loving it. If we can do play with this one. As you can see, it rotates. It just it stacks in one position. Sort of like it has to be planar because it's a planar projection. matters of phase one direction. But anyway, it's like for you to experiment on, so it's very cool. Um, but also what I want to do is to something sort of show you something very cool, and this is going to be our last example of like a sampler node. I'm not sure if you guys seen it on the example, on this given example here. I want to show you like on the first given, let me just have a look, which slide was it? Like here, as you guys can see, like this picture there, I want to basically show you that you can actually use what we call a mesh sampler. We can generate on existing PCG spawning meshes. You can spawn another meshes on top of the spawn mesh if that kind of makes sense. And I'll show you how actually you can approach to this given problem. So to do this, let's go back, and I'm gonna just remove this guy because we don't need him anymore. And let's just create a folder for this. I'm gonna call PCG spawner, mesh spawner. Let's say, uh, okay, yeah, mesh spawner. Yeah, let's call it. All right, so double click, and I'm going back to this. I'm gonna close this guy, and I'm going to first things first. It's gonna require two PCG graph for this reason. So we're gonna use this other PC subgraph. So before I can jump in, let me just do one more thing. So like at least I know what I'm doing on this given example. All right, so first things first, let's go and create a PCG. Yep, PCG empty, and we're gonna call this PCG point mesh spawner. And for this reason, why I call it mesh spawner, because we actually gonna spawn points on the other on top of the other PCG. That's why I call it point mesh spawner for this reason. So I'm gonna double click and let's create an algorithm. For this one, because this is a specific one, and because it's we're gonna use input and output, and because for this we're using input and output to access another graph. So this is given example, it's gonna be a subgraph which gonna be then used on the other PCG graph later on. So that's why we have to use input and output nodes for this given example. But first things first, because we're gonna loop this information through it. So every time anything that generates in space, it will also keep looping this point information into another meshes that are being spawned in space. So that's why for this one, we need to loop this stuff so that it keeps feeding the information as it's being spawned, and then spawns another on top of this given spawn objects, it will spawn more objects. So what I'm gonna do is first things is going to um, give it that we need to loop this. So I'm gonna set it to loop, and also we're gonna use points for this reason. Okay, so let's make it set to normal. All right, so that's exposed, and also what I'm gonna do, make sure this is points. I'm gonna also use point, and I'm also gonna set this to normal. Yeah, that's right. So for this, what we're gonna do, we need to make sure we are fitting some with some information. All right, cool. So what do we do here? Well, this is going to be a specific part of that section where we're gonna get attributes of some of the object and then replicate into like from the point index and replicate into a mesh that we're gonna work with. And for this reason, that's what we're gonna use get attributes from point index node as well as add it to mesh sampler. So for this reason, I'm gonna do is then a get attribute set from the index, sorry, from point index, and I'm gonna then add to the mesh sampler here. And for this, so for this one, because we're gonna use static mesh, which is already here, this is going to be our attributes, right? So also I want to make sure that all the information that we're working with is going to be input source as a mesh because we're going to use mesh for this specific example. Since we are dealing with mesh, make sure output attribute set to none because we're not going to deal with this. Our source is going to be this one. So I'm going to add this to connected to this. Our attribute set point from get attribute from point index connected to static mesh. Another thing I need to check out for, and I think it's good because we already have a spawning methodology of 1 point per triangle. So every time you have, as we have polygon in every triangle, there's 1 point dedicated to this polygonal mesh. That kind of makes sense, right? So on each triangle of this within this mesh, there's going to be 1 point generated. So we need to make sure we copy this information. We're going to have to copy those points. so that infinitely will, oh, infinitely, it will procedurally duplicate these points and copy them into another static meshes, if that kind of makes sense. So I'm gonna also make sure that transfer points also enabled because we want to randomize the positions of these static meshes that we're gonna work with. And this is gonna be our source, and also we need to make sure that our input sets is working with the target. Also, just to make sure, I think it's kind of legit here. Yep, it's fine. I think this is pretty much simple algorithm. So what's going to happen? Each point attribute from the point index is being translated to the mesh sampler, which then generates the static mesh. And then what happens is that the mesh that's being spawned on top of the other mesh has its own information. Like here, so what's going to happen? You can change offset, rotations, as well as scale them around. And then using this information, you can copy these points on top of the meshes that are gonna spawn later on within this mesh. That kind of makes sense. And then it sends this into output. This is gonna be our subgraph. So with this one, I'm actually happy. Okay, so next thing I'm gonna do is then yeah. So let's go to create another, in this case, mesh spawner. So we're gonna create our main graph. I'm gonna create empty CG. We're gonna call this mesh spawner. All right. And I'm going to then use this now to use this information. So I'm gonna drag and drop into this space, but because we gotta loop this, I'm gonna create a mesh spawner loop node. Now, cool. Let me just move this out of the way. We don't need these anymore. We only need this information here. So let me go and add like landscape data. Let me add surface sampler. Okay, let me connect these two. I want to make sure there's enough space. I'm gonna get this point extent to work within this given extent point space here. I'm also make sure that my thing works. So I'm gonna do this given a particular situation. I'm gonna have to put also at attribute partition. So then I know that I'm relocating this information, knowing that it's called a mesh, right? So the index we're currently working with, it's the mesh, the information that it loops from this node here. So because we already had the mesh, which is inside that subgraph, and we want to also know sure that partition-wise, the attribute is also set to mesh. Okay, so that works this way. I'm gonna just then click connect to this. But first things I need to also remove that because you always have to make sure you connect first these nodes together with surface sample, then connect directly. Then it doesn't have to translate into specific mode information. And what I'm gonna do is then add attribute. This is the very specific because we want to also make sure what we adding to this given so-called graph to make sure it spawns object. Well, for this reason, I'm gonna use chair, which is that from this example, as you guys seen it on that given picture, I wanna make sure these chairs from the Epic Game Starter content are being sort of generated on top of these spheres. So to do this, I need to also add this here. So I'm gonna make sure first output target set mesh, and I'm gonna set this to object path, which is my chair here. So I'm gonna set the chair. Let me go look it up. All right. And I'm going to do also I'm gonna transform points. Okay. All right. And then I'm going to create static mesh spawner. And let's have a look. I want to make sure it works. But first thing I need to make sure it's that it's work with attributes because we're using attributes here. It's called mesh. And I'm going to connect this guy here. And I'm going to then connect it to this because we also want to make sure that surface sampler sort of connected with transfer points to have a variety of different positions. So now, technically, let's hope this works. Let me check. Um, okay, but it's also another factor because we need to also make sure that what we're working with is this one, to give you an example here. So, because I need to also give information what exactly it's going to, this chair is going to be spawned on top of it, which means I need to also provide the objects that are going to be the main primary source of that spawning. So for this one, what I need to do is to introduce, call it dynamic mesh, right? So for the dynamic mesh is going to be our data asset. So Because Unreal has this option where you can store data differently. You can actually do static mesh spawner and expose these static mesh spawner, these meshes inside the entries, or you can actually do is to create a separate static, sorry, like a data asset where it holds all the information of the static meshes that you're gonna use within the PCG. So for this reason, what I'm gonna do very quickly, I'm gonna just basically do is then create a primary data asset. Let me just go first create a structure. So first things first, so go to Blueprint. S, I'm gonna call mesh. Okay, and double click static mesh. We're gonna use the static mesh for this, and I'm gonna call mesh here. I'm gonna also add a variable, and this is gonna be our weight, which means we can then use this to um, to distribute the amounts of weight for each mesh to be generated. That kind of makes sense. Um, also, cool. All right, cool. And I'm also gonna now go to Blueprint. And I'm gonna create this primary data asset, which is this one. And I'm gonna call PDA mesh. Okay. Double click, and I'm gonna do is then create a variable. I'm gonna look for the structure I've just created, mesh, right? So this is the one. Make sure this is also an array so we can add multiple meshes at the same time. I need to expose this, otherwise it's not going to work. So I'm going to also call this mesh. I'm going to call, oh, maybe let's call dynamic mesh. So it's a bit different this time. Dynamic mesh. Okay, cool. And then I'm happy with this one. I can just save this. I have everything I need. So now I can go and then create the data set based on this PDA information. So I'm going to go and then call PDA mesh. Select this. I'm going to go DA underscore mesh. All right. So now I can then add this, and then we can add our whatever we use to spawn our meshes, where these latent shell is going to be spawned on top of these floating cubes. We call these like spheres. For this one, I'm going to use mesh, which is the one that I have for this given example. We go, so that's a mesh. Yeah, this guy. I set to 1, and I'm gonna save him. I'm gonna make sure that it works. I'm going to my mess. Yeah, this is my mesh spawner. I'm gonna actually look for this so it matches and sets attributes of this given data that I've just created. But in order for it to work, we need to also add this as a parameter, right? So I'm gonna call this DA mesh, all right? And I am going to change this to what was it called? PDA, yeah, mesh as my DA mesh here. That's why it matches whatever it's there. And I'm gonna also get property from the object path. But because you can also basically drag and drop here, and that will feed this one, but also make sure the naming is exactly the same as the one on the PDA, which is the primary data asset. I'm going back to this. I'm going to call this dynamic mesh. That's right. I make sure this is matching my data. Let me just go and I'm going to plug this to this. Let's see if this works. Wait, my bad. Let me check. I want to make sure I got everything set up for this given example. Um, let's check. Yeah, that's the one. My sphere. Okay. I want to make sure I have everything set up for this example. Okay, I'll go. It looks like everything's fine. Um, okay. I think maybe it's what's missing. It's something here. Um, okay, something's not picking up for some reason. Ah, because I'm using the different one. So, um, my spawner. Oh, oh, something's happening. Oh, too much. Oops, I've killed it. All right, let's go back. I've done this because we shouldn't use unbounded. My mistake. Let me just turn this off. This should fine. Please don't crash. Okay, I think it takes time to. Yeah. Oh, it's okay. Let me turn this off fully. Cool, cool. Yeah, it's doing something. Please, please. Okay, turn off. Okay, cool. Now it's working. Yeah, so now you can see I've dragged my mesh spawner, which is the main, that's the main PCG graph volume, because I'm using my subgraph that generates these chairs on top of it. As you can see now, I have ability to then add this into this loop here. And by adding this attribute, I'm able to feed these, as you call these spheres, with these chairs on top of each other. So now, as here's a prime example how you can then spawn other meshes on top of the existing meshes that are already generated within PCG as well. So you can kind of like use PCG within the PCG, if that kind of makes sense, and you can utilize it a bit more further using other instructions however you want it to, and experiment a bit more on that too. So this is very cool because now you have the ability to do a lot of cool things with that, right? So I'm gonna maybe add a bit more variation there, so that's a little bit more of this. You can also offset it, so it does look like it's generic, I guess. All right, coolio. All right, so it's just basically you see that chairs are moving, so it's a bit weird, but it does some tricks to it. Yeah, so now I can then even use like I suppose like let me have a look. Landscape it. I can just then also maybe sculpt it a little bit like a little mountain there, cliff, and then I can then drag this into this given there. Okay, and as you can see, it snaps into oh yeah, let's just make it like that. Oh, within the volume space. Now you see. That's pretty much it. This is pretty much what it looks like here. Knowing exactly that we can play around with this more and more. No, and that gives you a little bit more variety of options there as well. So that's something for you to particularly work with this kind of exercises. So now you see it's cool. That gives you another form of like sort of in this case a variety of different options that are available within the PCG framework. And of course, if you want to possibly add different meshes, you can just double click on this and then add, for example, more meshes like here and make sure you set to one. And I don't know, let's just pick something from here, like a tree or something. As you can see, the trees are being placed there too. So it gives it like a bit different variety. So it's kind of randomized here. Looks weird, but does some tricks to this. So it's like a very cool, sort of experimental feature for you to play around with if when you have a chance to be very creative on that sense. So that you know that you're not only stuck to this sort of problem because you can also utilize this further using this kind of process of how you can use different structure of PCG to generate different results. Also, another fix I might do as well, because at the moment, as you can see, yeah, it's okay. Actually, I think it's fine. It's for you to play with this one. Actually, I was gonna say that, your now ability to do something with PCG, given that you have lots of examples here outlined now, is that you can do a lot of crazy stuff with that, right? So that gives you that a little bit of your chance to actually thrive to see how, you are particularly not just creative, but you have some crazy ideas. Basically, you can do is to test yourself out, see what other nodes does there too. Of course, there are a lot of other nodes that are introduced in Unreal, but obviously this is specifically new things. That's still something worth exploring. Even myself, I don't know many nodes there. I only know nodes that particularly creates my results needed for projects. But even though if you have something like equivalent to projects that you currently working on, feel free to just play around with more nodes there because there's plenty of them. There's also a section which unfortunately we're not going to cover in this kind of given exercise. Maybe next time as well when we're going to organize something new with Zubaida. Currently, is that we can also create with something called word partition runtime, where it basically works more with utilizing the that utilizes more PCG within the bigger spectrum of landscape, which means in other words you can create massive word without you going through the performance issue because what's going to happen in runtime will basically generate objects that you see that are visible to your eyes in front of you. So there's a lot of caveat there. There's a lot of going info, a lot of knowledge there to also share on that specific topic, which I don't want to dig into it because it's maybe overcomplicated for now. But there's something worth checking into in the next session when we have a time for this, obviously. But for now, very happy to guys present it to you what I've showed you guys so far. And at least now I'm very happy to be here. And if you guys have any questions, we can then step into later or now.